In this video, we are going to solve the equation the floor function of x multiplied by x minus the floor function of x equals to 1991 times x. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. Before solving this equation, let us recall the definition of the floor function of x, which is defined by the largest integer n such that the number inside the floor function x is between n and n plus 1. Or, in other words, it's the largest integer n that is smaller than or equal to x. For example, if we apply floor function on the number pi, then we have 3. However, if we apply that on minus pi, it will be minus 4 instead of minus 3. So if the real number x, the input on this function, is positive, then the floor function is actually just taking the integral part of that number. Now, looking at the expression x minus the floor function of x, by definition we know that it must be positive, and it's also always less than 1, because we have defined that the floor function defined by this integer n with x less than n plus 1. So we know that x minus n, or x minus the floor function of x, must be less than 1. So now we actually have the product of an integer, floor function of x. I shall let, say, n equals to that. And then p equals the difference between x and floor function of x. And now we write x as n plus p. And the equation will be rewritten as n times p equals 1991 times n plus p. Well, this equation is easy to solve because I can just put everything to one side. Let us write this as equals 0 first. And we can add 1991 squared on both sides so that the left side is factorizable, and then we can factorize. Like this. Now at this point, my strategy would be to make this number p as the subject, and make use of the fact that this number p is between 0 and 1. So to find out the possible values of the integer n. So let's try. Now p equals 1991 all squared over n minus 1991 plus 1991. And we know this expression is between 0 and 1. We can first divide the whole inequality by 1991 to make things easier. Then minus the whole inequality by 1. And so we have the fraction between minus 1 and minus 1990 over 1991. And again, divide both the all parts by 1991. And then we have much harder step, which is to take the reciprocal on all parts. So the middle part we have n minus 1991, and then for the minimal part, it is actually the reciprocal of the maximum part, and so we have minus 1991 squared over 1990, whereas for the maximal part, it will be the reciprocal of minus 1 over 1991 instead. And we have minus 1991 here. And finally, we have the range of n to be 1991 minus 1991 squared over 1990 and 0. So simplifying, for the number at the left, I can say is equal to 1991 times 1 minus 1991 over 1990. And eventually, we have minus 1991 over 1990 less than n, less than equal to 0. Now, we have a range of n, which is an integer, and from this we know that n can only take two values, which are minus 1 and 0. So we can make use of this and go back to the equation above and try to solve for p. Since we know that n times p equals 1991 times n plus p, so we can do that one by one. When n equals 0, then we know 0 equals 1991 times 0 plus p. That means p equals 0. And from this we know x is just n plus p, and that's 0. Finally, when n equals minus 1, then we have minus p equals 1991 times minus 1 plus p. And we can solve for p. On the left, we have 1991, which equals 1992p. And we have p equals 1991 over 1992, which is still valid because p is between 0 and 1. And altogether, x is n plus p, and that is minus 1 over 1992. And both are valid solutions. So therefore, x is either 0 or minus 1 over 1992. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.